Embedded Linux is everywhere. It powers industrial equipment, vehicles, medical devices, communication systems, and increasingly complex edge platforms. But when Linux becomes part of a product that has to operate reliably for many years, protect sensitive data, meet cybersecurity requirements, and potentially support safety or mission-critical functions, many questions become fundamental. How do you build a Linux system that you can trust? How do you maintain it over a product lifetime of 10, 15 or even 20 years? How do you understand exactly what's inside of your software supply chain? And how do you retain control over the technology your critical products depend on? These challenges are becoming increasingly important for OEMs and developers in industrial automation, transportation, automotive, aerospace, defense and other critical markets. And this is where Elenos comes in. With the launch of Elenos 8, Cisco is taking its industrial Linux platform another step forward. With a strong focus on security, long-term maintainability, transparency and European technology sovereignty. But what does this actually mean from an engineering perspective? What happens behind the scenes when you build an industrial Linux platform? And what makes Elenos different from simply putting together a Linux distribution yourself? To answer those questions, I'm joined today by David, Head of Product Development for Elenos at Cisco. Welcome, David, and please give us an introduction of your role.
Yeah, hello everyone. My name is David Engraf. I'm responsible for Elenos, our embedded Linux distribution. So with my team and myself, we are managing our distribution, looking at what kind of packages are interested for our customer. We're doing board support packages, porting Elenos on new customer hardware, providing security services and tooling around that. So basically we're helping our customer to generate their own embedded Linux distribution adapted to their boards and the needs.
Awesome, thank you so much for being here. So many engineers might ask, Linux already exists, so why build another Linux distribution? Tell us, what is so special about Elenos?
I think you have to distinguish between a Linux distribution running on a personal machine like a laptop or a computer. These distributions like Ubuntu, Debian, Fedora are mainly providing a very large number of features, of applications, libraries, so that you can do a lot of things on these machines. On the other side, when looking on the embedded market, customers really want to reduce the number of features, also attacker impact, for example, so really to adapt the distribution only to their needs. For example, also reducing the number of services. If you do not require an HTTP server, you don't want to put them on your target because it may open up security issues or attacker surface. So in Elenos, what you can do is that you start by zero, by having a very minimal system, and then you're adding on top of that more and more features depending on the needs you have. So for example, if you need a systemd init process, you can easily enable it and it will be automatically adapted to the needs of other services. You can add, for example, HTTP server, a graphical environment and all these things coming up, but they are not automatically integrated, so you are generating your own embedded Linux distribution only for this target board.
And then we say specifically that Elenos is an industrial Linux. So what does this mean?
The industrial comes from mainly because we are focusing on several markets where custom hardware is always one point where the customer is coming up and using some of the existing system on chips, but then customizing that on their own boards, doing some industrial specific extensions. And then Elenos comes into the game saying to run on those special hardware always requires some manual modifications of the Linux kernel, doing some adaptations of drivers. And this is mainly the point where you can use Elenos and where a normal mainline distribution may not fit on these kind of boards.
Okay, good. When developing Elenos 8, what were the primary design goals?
So basically we want to extend the number of boards we're supporting with the Elenos product. So we have quite a large number of new vendor BSPs integrated into the product. Therefore, Elenos runs out of the box on a quite large number of development kits and boards. And another large impact was as well the scope of security, and to increase on several parts of the product the security features, especially everything which is coming up with the Cyber Resilience Act. So for example, software bill of materials is now part of the product. It's not only having all those reports for the complete product, you can also adapt it to your project. So if you're having your own project, you may just use a subset of all the available hundreds of libraries and applications which comes with the Elenos, but the report will be generated for the project, so it contains only the real packages and information, which also helps to have a better feeling, and also in scope of security to better know what kind of dependencies and what additional services runs on the board.
Talking about cybersecurity, this has become a major topic in embedded systems. How has this changed Linux development over the last years?
Yeah, cybersecurity is a very large point here, because years ago most of our customers were satisfied by having a product, building their project and then running for quite a long time. Nowadays this is not possible anymore due to all those cybersecurity issues and vulnerabilities and also exploits coming up. So you need to constantly monitor what kind of vulnerabilities are coming up, and also need to do package updates, for example, on a daily basis, just to be sure that security issues are fixed. That means that we at Cisco are constantly monitoring public available vulnerability databases, and also on a daily basis do the checks for the product itself or the packages which are part of the product, so that we can provide these information to our customer, and also give advisories to the customer when a package needs to be updated, when there are security issues which are exploitable, maybe due to some attacker code. You definitely need to follow this, and this is also what we are providing at Cisco, is that we are doing that for our customers. So we are monitoring this, we are providing the package updates and the services around that, so that the customer can really focus on their development and their applications on the boards, and they know that we are providing the baseline with the operating system, with the packages, and providing security updates, so that they do not have to spend too many manpower on just the monitoring activities.
And how does this compare to using Yocto, for example?
Using Yocto is a very good system, because it allows you to, as Elenos, you can do a lot of configurations and adaptations as well. But on Yocto you always need to do a lot of things on your own. So actually with all those cyber resilience and security issues coming up, you need to have a team behind that who is constantly maintaining, updating the operating system, and so on. And this is what we are doing at Cisco for our customers.
Elenos 8 introduces integrated SBOM generation. Why is that so much more than just another report?
Yeah, the software bill of materials gives you a more detailed view what is really inside of your product, and also inside in your project you're currently working on. Sometimes there are dependencies on libraries you may not know that these are available, and if there are some security issues coming up, you need to know if you are affected or not. And the SBOM gives you all those details, so it provides you the information which packages are part of my project. Also gives you information about the licensing, which is also quite relevant for a customer, but gives you a much better overview of what is running in terms of software on the board.
Another interesting feature is the ANSI hardening certification from the French Cybersecurity Agency. What does this actually test?
Yeah, basically the ANSI provides a very large list of guidelines and rules to secure a Linux system. These are something like 70 or 80 rules. And these rules describe how to secure such kind of system. And depending on the number of rules which can be approved by the current setup, you reach a specific level. For example, it starts with a minimal level, and it goes up to the enhanced and the highest security level. Which means, for example, that you need to enable a user, disable a root account, disable services which are not required on the system. Enable SE Linux, for example, is one of those points, really to secure a system. And what we have in Ellinos are, first of all, we have a feature where you can specify a specific level. So if you really want to go to one of those highest level, our feature configurator will automatically enable the required features, and also make sure that there are no additional services running on the system which may impact the system or have an attacker surface or some other network services. And on the other side, we have a test suite, an ANSI test suite, which checks the current running system and provides you information and checks all the rules if these are fulfilled or not, and gives you some information what needs to be done to secure the system even more. And at the end you will get a report which level has been reached. So for example, if there are some security features missing, you may just have a minimal level, but if you fulfilled most of the rules, you may get to an enhanced or the highest security level with that.
So this means the ANSI certification really helps to prepare for regulations like the Cyber Resilience Act, right?
Mm-hmm. Yeah, it's a very good baseline, because if you're looking, for example, on medical devices, you definitely have to make sure that these devices are locked, that it's not possible to connect to those kind of devices and do some hacks. And the ANSI test suite also provides the details when running on those boards. If there are some security issues or some attacker surfaces, when there are some systems or services running which should not run on those targets, it will also make sure that the root file system maybe cannot change, or that the user rights and access permissions are correctly set. So it really gives you a good report as a starting point, where you can say, okay, we did a deep security analysis to make sure that the system is in a good and correctly configured manner.
Okay, interesting. And how else is Ellinos helping companies?
Basically by its design on security, because when you're creating a new project, there are no additional services, so you can really configure the project starting by zero, adding the required services you have to do. Also, the number of libraries is very, very limited, because the system, the Ellinos projects, will automatically analyze your applications and will integrate only the libraries which are required to run your applications and the services. So you have a very minimal system, and this by design is already a very, very good approach to fulfill a lot of regulations and stuff. Then on top of that, with the ANSI test suite and the other features we have, you can even more secure the system. What is also still quite often mentioned is the immutable operating system. It's also a term which Ellinos comes with out of the box. It means that you have a root file system which is in a read-only state, and you're running basically your applications in a separate container. So in Ellinos we have support for Docker and Podman, and so these services are already available, and you can really create by just a few clicks. When creating a new project, you can create an immutable OS and then add your own applications via container images to the system and extend the functionality, but always in a very secure way.
We state Ellinos is the European industrial Linux. What does this actually mean, and why is digital sovereignty suddenly becoming an important topic for embedded systems?
So first of all, we are ITAR free. We do not have any regulations in terms of using specific parts of our software, like cryptographic libraries. So this is probably one point. Another point is that we as a European company are located here. Yeah, we can support our customer directly in terms of having the open source software in our own servers, so that we are not relying on machines running outside of the European Union to provide updates, to monitor security stuff. Especially the EU is building up their own vulnerability database. So this is something where we will have a deep look into, so that we can provide those EU-specific vulnerability details.
We already talked about Yocto and how many embedded engineers know the complexity of building such a system. So how does Ellinos simplify the everyday development?
Ellinos is much more focused on the user and what he wants to achieve with the final product he wants to run on the board. So what we are providing with the Ellinos is basically a graphical environment as well as command line tools. With our graphical environment, it's much easier to set up a project and set up your systems. There we have a system called a feature configurator, which combines the kernel configuration as well as file system integration. So when you're thinking, for example, you would like to have an SSH daemon or a Qt framework running on your hardware, it's quite easy with the Ellinos, because we have separated features for that to make sure that that the right kernel configuration will be enabled, like the graphical support is in the Linux kernel available for your board, as well as the libraries which are required to run those applications. And we also provide configuration snippets, so that everything works like just enabling a specific feature, and then you will get all the support for that on your target without thinking about modifying some configuration files or XML files on the command line. That's quite easy to set up the system. And when you're looking at Yocto, it is a very complex system, especially when setting up the first time, because everything is built from source, and it has a large dependency also on the build machine where you're running or where you're setting up the Yocto system. In Ellinos we have a different system. What we are providing is, of course, the Linux kernel itself. It's completely in source because it depends on the boards and the drivers, and we all really want to have a Linux kernel which exactly fits into the board, which will not provide any more driver which is not used or functionality which could impact the security of the whole system, but really to have a reduced surface. And on the other side, the packages and the libraries are pre-built already on our build machines. So it's much easier setting up a project, and it might take less than 1 or 2 minutes to create a project and have the final image for your hardware to run on the board. And everyone who is working with the Yocto knows that it takes a lot of time for the first time setting up those kind of projects, and with compiling all the host tools on your own, then you may have dependencies to some host libraries, and this is what we are already doing in our specific environment. We have build machines, so the whole Ellinos product runs on several Linux distributions and has been tested on different Linux distributions, but we are also running with a Windows host system. Our product is really operating system agnostic, so we do not have much dependencies, and the Ellinos itself already provides a very large number of cross-development environment, including the compiler for C code or Rust code, for example. We provide a debugger, we have performance tooling, and this is already part of the whole product. And you don't need to install anything on your machine independently if you're using Windows or Linux. So the product comes with all the tools you need to develop your system and develop your application and work with what we have.
Ellinos has always been providing some very strong security features that are now even more important, talking about secure boot or secure over-the-air update. What makes Ellinos so strong in this area?
So secure boot is a topic where the Linux system is one part, but you need to have a global focus on the whole boot chain. And what we provide as a service is that we guide our customer as well through the whole chain of secure boot. So that means that we are looking on the target, we are checking the bootloader, for example, the U-boot. The configuration, is that okay? Are the certificates okay and correctly configured? How is the handover to the Linux system and to the file system? So customers who would like to use secure boot always need to think about the whole chain, and this is where we can help our customer as well, so that they are in a good position to know that there are no major mistakes or incorrect configuration, for example, which may break the secure chain of boot. So there we can help them. And what we have in Ellinos as well is over-the-air update tools. That means that it's quite easy, and we have also templates for that, which can be easily enabled. That we have a service, a daemon running on your target, and it's possible. It provides a web server if you would like to update the image via a web client, but it also allows to completely integrate the update process in your own application. Also in scope of having certificates, and certificate check is also implemented. So there is a secure way to upload firmware images, and the tool we have can do a full system update, but you can also, for example, just exchange single applications or container images. So it's fully adaptable, and you can basically fulfill all the requirements you have to have the system in a updatable and in a good state.
We have touched on quite some of the key engineering challenges and the powerful features that Ellinos 8 offers. If you're interested in getting your hands on our software, go to cisco.com/getellinos and try our free Ellinos test version to explore what's possible. In the second part of our TechCast, we are going to take a look at how you maintain a Linux system with a long product lifetime. How do you handle security updates and kernel evolution without putting an established product at risk? And what does professional long-term support actually look like from the perspective of the engineers developing and maintaining the platform? That's what we'll explore in the next part. So stay tuned and see you there.